Welcome to the Jack Westin MCAT Podcast with your hosts, Michael Maleka
and Molly Kilty. Hello, everyone, and welcome back to another episode of our Jack Westin MCAT Podcast with your hosts, Molly and Mike. I did that one just for you, Mike.
You did it just for me.
I hate it when I flip our names. Okay, fine. Mike and Molly.
I knew you would do that too.
I know. We've got a super fun episode planned for you guys today. It's actually one of, I think, both of our favorite things to talk about with students because it is so universally feared and hated. Mm-hmm. It's a strategy. See if you can anticipate where I'm going with this. It is
data interpretation. We love it. I already know someone was listening to that and they were like, I don't like this already. Oh, they got chills. They're like, oh my goodness, ew. But this is such an important thing to talk about because you're totally right, Molly. I love talking about this with students because this is one thing that is everywhere on this exam, right? You know, except cars, but cars we don't talk about there. But in the sciences, right, data interpretation is a critical part of all three science sections. And I would say like every science section you're going to need to use it. Like I can promise you on test day, you will need to interpret data in Chem, Phys, Biochem, Psych. So yet, this is one of those skills that students really struggle with, right? Either the data is like, oh my gosh, it's so complicated. I don't even know what I'm supposed to be looking at. What am I supposed to be focusing? Or even on the questions, right? Because sometimes these questions are not the most straightforward when it comes to what they want from the data. It's not just look at the data, what is the picture, right? You have to actually understand what the data was trying to tell you, what's the message. And a lot of students struggle with that because these are skills maybe we never had a chance to develop before because we've never been asked to kind of interpret data in this way. And so we have really set strategies. We've got processes for interpreting data. We've got mindsets that we're going to be talking about today. So super hyped and excited to talk about data interpretation today.
Yeah, and you're so right. I don't think that for the vast majority of us, we were ever formally taught how to do this. Okay, I actually went to a research-based institution. Every single one of my professors is paid a lot of money to teach at my institution because they were doing really fascinating research. I went to a UC school, and UC is like known. Every professor is doing crazy, groundbreaking things. And even in that environment, I was never taught how to interpret data,
it was just
how to effectively read a science research paper. Like it was just kind of expected that you just figured it out. But like I didn't really have assignments that required us to read research papers that often. I was never taught how to navigate these things. So when I'm, reading a science passage and suddenly I have to interpret data, I think especially back when I was first starting, I fell into that same loop that a lot of us MCAT students fall into of, am I supposed to be able to look at this and figure it out? Right? That uncertainty leads students to do one of two things. Either, nope, I don't think I'm responsible for this. I'm going to skip it entirely. I don't even want to look at it. It stresses me out. Or I think I am responsible for it, but I don't know how to break it down. So let me stare at it for 5 whole minutes and see if it makes more sense. Okay, so really my goal coming from a very personal connection to this is to help you figure out what you are responsible for, what to do when you are struggling, and of course, how to navigate it like an MCAT expert. So yeah, I think this topic, we couldn't have talked about it at a better time, especially as a lot of us are kind of beginning our MCAT journey and really hitting the gas with practice.
Right. And so I kind of like first starting when it comes to data interpretation on like what students normally struggle with. What's the challenge students have when they interpret data? And I've heard so many, like Molly, I'm sure I've heard some, and there's gonna be some that you've heard that are completely different. But one of the biggest things I hear, and that drives me nuts, is, sometimes this data is super overwhelming and I just skip it. And then I read the data and I see it over, and then I go to the questions. And if the questions ask me about the data, then I'll go back and actually look at the data. I hear this one, I don't know, like probably the most, and they're like, oh, that's what Reddit said. And here's my thing. I couldn't disagree more. I am so against it. And here's why. Again, I'm going to show my work here. Here's why. We don't like doing this because here, One reason is a lot of the times figures and data are in the middle of a passage where there's going to be some text, and we'll talk about the kind of anatomy of a research-based passage, but a lot of times there's text before, then there's the data, but a lot of times after the data, there's more text, there's more information. And a lot of the times that information will expect you to understand what happened in the data. Whereas if you skip that figure, you skip that data, you just read through, you read that second paragraph, and you're like, I am so confused. What are they even talking about? And so that's one really big reason why. Reason number A, why we don't skip data. Reason B, why we don't skip data, is there's a big assumption students make by saying, oh, if the questions ask me about it, I'll go back. Right? A big assumption is that the questions are going to say, oh, go look at figure 1, go look in figure 2. News flash for everybody. They don't owe you that. They don't have to say, hey, according to figure 2, sometimes they do, and that's great, that's fantastic, that's lovely. They don't always have to. So a lot of times what I find, right, if what I'm about to say relates to you, again, I was there, I was in the same boat where sometimes we read the passage, skip the data, go to the questions, and then the question doesn't say it's from the figure, but then it's asking about something you never saw in the passage. And you're like, oh my goodness, they didn't say that in the passage. And then we start rereading because we're like, oh, I must have missed something. And we spend like 2 minutes like just rereading the whole thing. We didn't find it. Now we're stressed. And then maybe now we like, oh wait, maybe I should look at the data. And then it was just right there. It was right there the whole time. And now this wasn't all that. Or maybe we don't even realize the data. We stress, we pick an answer, we move on, right? When it was just right there in the data. So those are kind of my 2 main kind of points to say, please, for the love of everything, don't skip your data. I get the argument, oh, what if they don't ask about it? You're gambling here, and plus, it's not going to take that long as you do it correctly, like Molly mentioned.
Yes. Yeah. And I was going to say the same thing. When you said A, I was like, IFB, call me. Like people are like, I'm going to skip the figure because if they ask me about it, I'll go back. I will also say, unless you have most of the time, if you have a passage that has 1 figure and you've got 4 or 5 questions, you can expect that you're going to see at least 1 question about the figure. Okay. If you have a passage that has 4 figures, okay, and 4 questions, you may not see a question about every one of those 4 figures. Okay. They could, but they don't have to. A lot of students go in with the expectation like, oh, they almost never ask me about the data. No, they will. They will. I can't say that every single figure that you will be shown on your exam will have a question about it. Okay. It won't be that way, but most of them will. Okay. If you have data in your passage, expect at least 1 data related question. Okay. Again, if you have a ton of data, okay, they might be asking about one experiment or 1 figure and not the other, but you don't know that ahead of time. What Mike is hitting at here is really important. When you skip things and then go back to it later, not only are you not 100% sure that you know where to go back to because you didn't actually look at it, but also you're going through the passage in a very fragmented way. Like he said, if you are supposed to understand figure 1 and then you read another paragraph that helps you understand it or that adds to what you understood from figure 1, even if they tell you, something that clues you into the data, if you just go back and look at that without a full flow understanding of the passage, you might miss a connection that was actually made in the paragraph right after. So like, please, even if, I'm not telling you to take 10 minutes to read the passage before moving to the questions. I'm not telling you to stare at data for 3 or 4 minutes before moving on, right? We need to go through these things quickly and efficiently, but we need to look at them. Okay. And we will talk about like, what is the most ideal situation if you want to truly understand everything? And then what if you are like Molly and Mike, I don't buy it. I'm already stressed for time. I can't do this. We'll give you the minimum effort. Like at the very least, this is what you need to do.
The bare minimum. It's like the bare minimum treatment. Yeah. That we can do for data.
Yeah. And we'll talk about when to move on if you really, truly are stuck. Okay. Because we don't want you to dive in too deep. Again, I was telling Mike, it's like the Goldilocks zone. Right? You don't want it to be porridge to be too hot. You don't want it to be too cold. You want it in the middle. You don't want to spend too much time. You don't want to skip it. You want to find that middle ground. And I personally adore the strategy that we have, especially in talking about pitfalls. The strategy that we're going to talk about, it's called TAUT. Title, axes, units, trends. And the pitfall that I see students make all the time is actually just I don't read the title. I don't do the title. I don't look at the axes. I don't look at anything else. I just look at the data, and that is problematic. So
Mhm.
I'm very excited to talk about this because ultimately there are so many different pain points that you could experience. And we've essentially established a 4-step system to guide you through any figure, no matter what it looks like. And you are learning things at every stage such that when you get to figuring out what the trend is, you already have such a good idea of what information is there that you don't have to feel like it's all or nothing, right? It's like taking the stairs up, from floor 1 to 2 instead of expecting to just leap to the second floor of a building, right?
Right.
Take the stairs. That's
Right.
what that's what taught is.
Gotta put in the work, right? A lot of students are like, "Oh, why don't I just get it? Like, why aren't I at the top of the stairs right now?" Like, no, let's do the process. And then hey, you'll before you know it, you'll be at the top, right? But it's all in the process, and that's really, really important.
hmm
Mhm.
Yeah. So, I mean, before we dive in with the specifics of taught, again, I feel like we've kind of covered some of the main pain points that students have. Again, I think we go way too in depth or we tend to skip it. What I think students don't really fully appreciate is that the figure not only is high yield, okay, it's not just like important, it's also the essentially the summary of the findings of so much hard work, right? I feel like it feels different in MCAT passage than when you read research papers for real, but like recognize that there's a person, probably a group of people, possibly a very large group of people, that put their blood, sweat, and tears into designing this experiment and collecting this data. And this is their like cherry on top. This is what would go on their poster presentation. Like this is the data. They put in so much work for this, and every figure tells a story, right? It's telling you about what's going on with these individual molecules or what the summary of energy change was in a chemical reaction or whatever it is. But it's telling you a story. That story is important for the questions, but also it's cool.
It's cool. That's the
It's
big thing.
cool.
It's such an interesting thing. And
Yeah.
this is where so many people like roll their eyes when they listen to us. But
Yeah,
like
they're like, okay.
okay, I get it. But this is truly one of the big parts of the MCAT where it's like these passages are really interesting. A lot of us look at these passages like, oh, I have to do this. Oh, I have to go read this bio passage. And not only does that limit you when it comes to the questions because you'll be less engaged, but like if a lot of these like scientific literature doesn't excite you, again, I mean this in the nicest way, like, are you in the right field? Like, I
Yeah.
gotta like
Yeah.
this is the really cool stuff. This is the stuff that advances. This is stuff that helps patients down the line. And so and I found this time and time again, a lot of students when they start, it's like, oh, I need to do this. But I noticed the scores don't increase a lot of the times when they learn the strategies. The scores increase when they start enjoying the passages, right? A lot of the times I see like huge score increases, and when the student comes to me, they're like, "Yeah, I thought the passages were really cool, the ones that I was talking about." I'm like, "Oh, no wonder your score increased because you were far more engaged. When you're interested, you draw connections way more rather than I need to do this." So you bring up great points like, no, I don't want you to treat this like, oh, I have to do this because it's an exam. These passages are interesting. We should treat it
Yeah.
as such.
Yeah. And I feel like another element of it, like there might be students out there that are listening to this and they're like, Molly, Mike, I want to be interested. I find them interesting, but I can't engage with that interest because I'm so scared. Okay, so I
Mm,
feel like you need an interest in the material or at least a curiosity, right, about things that you aren't aware of yet. Which that is key for medicine for sure.
right,
But then
right.
also you need a strategy. You need something in your toolkit. You need to know
Mhm.
what to expect so that you can set aside the fear and actually engage with the passage as it is, because that's when you'll find the spark of interest. So let's get into more of the nitty-gritty. Okay, so
Mhm.
we've established we need a strategy. We want to be interested. How do we get there? I think it starts with understanding what you will be exposed to in a research-based passage. Okay, because a lot of what you need to do and unpack in the question or in the figure itself and the question, it actually starts earlier. Okay,
Mhm.
so if I walk you through just kind of the anatomy, so to speak, of a research-based passage, for the most part, we're going to start off with at least one paragraph, maybe two, with background info. So, depending on the type of passage, again, this could be in any science section, You might get new molecule names. You might be getting particular enzymes or inhibitors. You might get a signaling cascade. Maybe they're describing a particular physics experimental setup, or like they're setting the stage with, I'm looking at this particular bacterium or this, cancer cell line, right? Like, what is our goal? What are we studying? This is the area where they kind of get you up to speed with what you're about to study, right? Or what they are going to be studying, right? This is typically at the beginning, and it's going to have a lot of new info. So use your highlight tool. If you get buzzwords, if you get names, right? Anything that's one word, maybe two, that's good for quick reference, go ahead and highlight. Also, feel free to use your scratch paper. Okay. If you get what feels like a content-y question, background info is probably a good place to look. We'll also talk, sometimes it can come from methods, but background info, pretty much always there, at least a paragraph, even if it's short. Like, hey, we're talking about hypertension that's resistant to medication or whatever it is. We're talking about vasoconstriction, right? Then once they've set your stage, they've given you context, they're going to give you their research question. And this, I feel like most people read past. We don't know how to find them often in the passage. Sometimes they are very explicit. They're like, the goal of this research
Or the
was
researchers
to-"
set out to. Yeah.
literally, and this is like, for anyone who's brand new to the MCAT, this is not always true, but it's true like at least like 75% of the time. The sentence starts with researchers.
Yeah.
It almost always does.
It's like the fact that pattern is like the researchers set out to, or researchers set out to do this thing,
Researchers
or
assayed the effect of this, or researchers investigated this, or researchers evaluated this or this.
experimenters. They get there's experimenters too, but it's always
But they don't even. It's always researchers.
a lot of times it is just researchers, but a lot of times, and it's so funny, after you've done a few passages, you kind of just skim over. They're like, okay, they asked to do the research thing, but no, that's not the sentence to skim over.
Slow it down. Yes.
That's the one to focus on, because that's the whole goal. All that, because you bring that up so well before. They usually bring this whole background, right? They have this whole background, and this is the part where students kind of like, a lot of times students like skim over it. They're like, okay, cool, this relationship. And then the research is when they keep on skimming. No, that background was important to understand, so that when they ask, hey, we just said all that, but there was this cool interaction between these two proteins, between these two relationships. There was this drug. They wanted to see its effect. And so this is the time where I see it a lot of times where students come to me and they're like, and they probably come to you because Molly hosts office hours and is great. You should go check her out. And they say, I suck at data interpretation. I really struggle with data interpretation. Maybe you're using the strategies that we're going to talk about today. Maybe they've heard about them, but they're still struggling. A lot of the time, students struggle with data interpretation not because of the data itself, but because they didn't understand the stuff that came before the data. They didn't understand the background information. They didn't understand why they even did the data in the first place, right? Which is the research question, which is that sentence that says the researchers set out to do X, the research set out to do Y. Before you jump into any data, in my mind, before we start doing taught and do all those things, you should know, why are they doing this data, right? If you don't know that question, there's no point to even continue, in my mind.
Yeah, absolutely. And you need to know what to expect, right? Because again, I keep using the analogy with students. I was just talking about this in general office hours. If you go into a research figure with no context, it's like trying to put a puzzle together without knowing what the puzzle should look like when you're done. You're just like picking up individual pieces like, those don't fit together. I'm just gonna set those aside. Let's try these two. Like, you got to know what you're expecting to see when everything is understood. Okay. And this is giving you that framework. It's at least helping you understand, what is the researcher investigating? Like, what might I see in this data? What are my variables? Okay. And again, an independent variable is something that the researcher is intentionally manipulating. They have control over it and they are changing it in order to investigate it, right? And then typically we see some change in another variable of interest that the researcher is not directly manipulating. They're just measuring how it changes. Again, the goal of an experiment is to keep everything the same between trials, except that one thing that we are manipulating to investigate. And then, of course, whatever is changing in response. The goal is to figure out a cause and effect relationship, or as close as we can get to it. The more control we have on every other possible variable, the more confidence we have. Okay, but the trends are going to ask you, how does the independent variable impact the dependent variable? And for that question, right, if you're asked about trends, you need to know what your variables are. At this point, personally, I don't think you need to write it down, but you need to pause and reflect. What are my variables? What am I studying? Okay, we'll talk if you like to have those things jotted down. We'll share a way to do that that's a little more time and space effective. But I mean, when you read your research question, pause and reflect. This is the overall point of the rest of that experiment. Okay, keep that in mind. We'll also talk sometimes what you see on the axes of your research figures, right? I don't want to get ahead of myself, but a lot of students are like, oh, the variables in research are just what are on my axes. And that is a great place to find it. But sometimes the stuff you see on the X and Y axis of your research figure are not exactly the same as what language was used in the research question. And so sometimes they use the language of the research question to ask you about the figure, and students get lost. Okay, when you find your research question, do not pass go until you have unpacked it. Okay, you don't need to write anything at this stage, but it's critical. And I think a lot of the pitfalls that students fall into later with taught and actually looking at the figure itself could be greatly reduced by reflecting on the research question when you find it.
And it's so great because I see so many examples, especially in the section bank. The section bank volume 1, I think, does this a lot. Like chef's kiss, right?
I
Because
love it.
right.
My favorite.
Section bank volume 1 for context is like a question bank in the official AMC, and the section bank volume 1's been around for a while, but it's very representative of test day in that it's got a lot of database, like data focused research focused passages, and they ask a lot of questions that focus on that data. I don't want you to think, test day is going to be all like section bank volume 1. Actually, I remember I was shocked one time how Molly prepped for her exam. I'm kind of outing you here, Molly, where it's like you took like essentially 9 passages or 10 passages from each one, just made an exam out of the section bank volume 1. I would never recommend anyone do that because the section bank volume was just way harder because it really focuses on tough aspects of the sim, but therefore it's a very good way to prepare. The reason I bring it up is in section bank volume 1, they do this a ton where they bring up a research question. They say, we want to measure how does this drug affect binding affinity? And then the y-axis was fluorescence. And you're like, wait, I thought we were measuring binding affinity. Oh, no, in the methodology, they said, fluorescence was used to measure binding affinity. Because we didn't make that connection between the two. When the question's asking about binding affinity and you don't see it on your graph, you're like, oh my goodness, what is going on?
Yeah.
Right? They do this with all sorts of things when they talk about health. Oh, how does this medicine affect health? But then they were measuring, blood glucose levels. I don't know, I'm making stuff up now. And it's like, oh wait, I thought we were looking at health. Why are we looking at where's the health on the graph,
I know. I remember so specifically the first time that I got kind of smacked in the face by AMC doing this. It was a Psych Soc passage, and they were measuring sympathetic nervous system activation. And so I'm expecting to see sympathetic nervous system activation on my graph, and it was skin conductance. And I was like, huh? But it has to do with sweat.
Right.
The skin conductance goes up when you have water and ions on the surface of your skin. So it's like skin conductance goes up when sympathetic nervous system activity goes up. It's called operationalization. If we have something that we want to study that's kind of hard to objectively measure, we redefine that sort of abstract variable as something specific. Think pain scales, like pain. How much does it hurt? A lot?
Yeah.
Okay, from 1 to 10, 1 being the, completely mild, 10 being the worst pain you ever felt. Now you have a criteria, and I could give you a number that's more specific, more quantifiable. So watch out for this. And again, research questions tend to have the more general abstract variable. The actual data is going to tend to have the very specific measurable and quantifiable data or variable because it's part of the data.
Right.
So again, they love to do this. They'll ask you which of the following is true about this abstract variable, and you need to use your data. Okay. I feel like we've been on this tangent for a while. Research question is important. That's your
Super
take home.
critical. Super critical. And
Don't
so
pass go.
and so when we were kind of going over the anatomy, right? You have the background, you have your research question, and then right after this research question, this is the part where we see students do two very different things after they see the research question. Because right after they see the research question is normally the methodology. I'd even say like 90% of research-based passages, before they actually give the data, they give like a short little mini paragraph on like, oh, how do they do the data? And in my experience, I've seen a lot of students that they see the methodology and they're just like, okay, cool, and eyes glaze over. It's like eyes glaze over and they don't even look at the methodology. They're like, cool, 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 cool. Okay, let me look at the data. But then they're like, okay, wait, what do they even do with this data? Right? On the other side, I know Molly, you see this one a lot. It's so funny how we see two very different things where a lot of times students get so bogged down by the methodology. They're like, wait a minute, why did they add this compound? Let me sit here and think about it for like 3 minutes because I don't understand. Let me reread it over and over again. Right? Where there's a happy medium when looking at that part after the research question normally, which is the methodology. The big question you should be asking, because they're going to be saying, oh, they used this compound, they did it for this amount of time. Simply just ask, how does adding this compound, doing this thing, help me answer my research question, right? Oh, they're measuring, they maybe, a lot of the times they actually do that operationalization in the methodology. They say, oh, then they measured, sympathetic nervous system with, skin conductance. They'll say that in the methodology, right? Or maybe they'll just say, they measured skin conductance using these electrodes. Okay, so remember using the research question. So with the methodology, when you see all these compounds that using this time, they add this inhibitor where they say, oh, we have this one as kind of a control. Simply just ask, why is this there? Right? Don't sit here. And if you don't have an immediate answer, a lot of times that's okay, but at least you took the mental effort to actually look at it and you didn't just glaze over, but you also didn't stay here for too long.
Yeah, I feel like this is a place where, a lot of students panic because this tends to be a place, depending on the type of passage, that you're going to find a lot of buzzwords and values with units. Like we added 0.1 molar concentration, or we added 10 milliliters of 0.1 molar concentration of this and 100 milliliters of 0.7 molar concentration of this. We mixed them together with this present as a reagent or this, or in this solvent, and then we expose them to size exclusion chromatography, blah, blah, blah. It's like, oh my gosh, like there are so many things going on here. How am I supposed to keep all this track? Like, what is going on? If they're telling you their goal is to separate a group of amino acids based on their size, and they tell you they're using size exclusion chromatography, it's like, okay. Like, yeah, I don't need to be asking myself, well, why didn't they use electrophoresis? Why didn't they use it? I don't care, right? What was the research question? I'm reading the methods through the lens of why was this the choice? How does this help me? Okay, not why did they make this choice, but like, how does this help me answer my research question? I want to add one thing here with methods, and it's just, this is the easiest paragraph to come back to, I think, of the whole thing. Like background info tends to be really dense. Again, highlight for sure, but map too if you need it. Methods, if they ask you a question about the methods, it's going to be like, what was the molar mass of the, or how many grams of particular solute was added? And it's like, okay, well, I have a molar mass and I've got a number of moles and I know the molar mass, or I can calculate that. And they're asking me for just the mass. It's like, I know what I'm looking for. Of course, it's going to be in the methods paragraph because this is highly specific to the setup of the experiment. Or like, which is true of the separation technique described in the passage. It's like, okay, well, that's going to be in the methods too. Now it's just, I found my size exclusion chromatography and I'm done, right? The methods paragraph, it's typically the questions they'd ask you about that material. It's pretty clear and obvious that they're asking you about methods. You can always go back. Okay, don't skip it. But like, I think it's probably, of all the parts of a research-based passage, I think it's probably the most like cherry pickable. It's it's the easiest to go back if you need it and just grab what you need. Okay. Still try and understand it, but it's easy to refer back to if you get a question about it. I always like to add that because the rest of the passage can be pretty difficult.
And relationship, connecting things, right? Whereas in methodology, it's like, oh, I can see that experimental methodology here. Because they'll throw a lot of like buzzwords. And if you don't know what buzzwords are, check out our Go Mastering a Science Passage episode. We kind of really kind of dove into how to read a science passage there. But there's a lot of like buzzwords in our methodology normally that you, when you're reading it, like, okay, that's a buzzword. Okay, that's a buzzword. So that you can go back and be like, oh yeah, there, that's the methodology. Oh, numbers with units. Oh, there's that concentration that they used. Okay, I can go back there. So totally agree. The relationships there, not nearly as, present as in, the background. And
Yeah.
so that kind of brings us to the kind of the real, like the magnum opus of a research-based passage, which brings us to the data. Because normally you've got the background, you ask the research question, they say, how are we going to do this, pursue this research question? And then they actually do it, right? And that's what the data is. And this kind of leads us really well into, I think, the kind of real, how to actually look at this data. Because now we've gone to this point, we understand the methodology. Now, okay, I have this picture. Right? And this is where I want to introduce the strategy that we kind of been referring to as TAUT. T-A-U-T. Whenever you see a figure, whenever you see a table, whenever you see a graph, this, in my mind, is the first thing you should be thinking. TAUT, right? And so the reason I love structuralizing things, right? Making it, because you might be asking Mike, right? I don't need a handhold. I don't need a strategy like this. I'm very good at data interpretation. The reason having something like this is so important is because when we don't have a structure, we're liable to make little mistakes. Right? And we'll talk later about what those little mistakes are to avoid, on why these avoids are. But having a structure like this is super critical. So let's first start at the first T, right? The title, right? And I know Molly, I know you love talking about the title, like the title of a graph.
I do, and it's because so many people are like, the title's stupid. Like, I don't want to waste my time. Molly, I'm tired. My brain is not working. I'm not reading the title. I don't want to read one more word than I have to. And I'm going to say, yeah, you are. You're going to read the title.
I don't
Please
care.
read the title. Please read the title. For one of two reasons. Okay, most often students tell me they don't want to read the title because they're already tired and they're already pressed for time, which, by the way, to Mike's point earlier, that is also why it's really helpful to break this down into discrete steps. You might not need a strategy like this if you are just doing one passage and you just woke up, you're feeling good, you're feeling fresh. You're going to have to do this in Psych Soc. And I will tell you from experience, you are going to be exhausted, zero brain power. You need a objective, clear, easy to remember set of strategies so that your strategies don't fall apart when your exhaustion kicks in. Okay. But title, most people tell me, I don't have time for it. I don't think it's valuable. Okay. One of two things is going to happen in your title. Okay. Either you're going to get brand new information. So they'll tell you about significance. Sometimes they define an abbreviation that's in your trends, right? Or that's in your figures. Sometimes they add a new layer to the data in there. Okay. There can be new information in titles to the point where if you don't read the title, you have no idea what's going on. Okay. Please read your title. The other option, let's say there's nothing new in there. Okay, sometimes there's not. Sometimes the title's just a restatement of your research question. And some students are like, if it's a restatement of my research question, that's extra time. I don't care about it. That's a gift. Okay.
I'm
That's
like,
a gift.
amazing. Amazing.
To read a 8-word summary of your research question right before you look at your data is an absolute gift. Okay. At the worst case, and I'm doing air quotes if you're just listening, in the worst case, they give you a restatement of your research question so that you are totally refocused. Because keep in mind, research method or research question is typically given before the methods, which has so many random things it's throwing at you, numbers with units, buzzwords. Having that before you start looking at your axes and the trends and the units, axes, units, and trends, that is a huge gift. Okay. It's telling you what information is in the figure. You need to read your title. I know it's tempting. There are times that, and I've taught office hours for Jack Westin for many years now. Like there are so many questions that I've had students ask me, like, I don't understand why this is the answer. I don't understand how to interpret this figure. And so often there's a huge clue in the title. And I'm like, did you read the title? And they're like, no, title's stupid. I'm like, please.
Go read that thing. Go read that.
Just read it. Will you read it out loud? And they're like, oh,
right. Yeah. All the time. And honestly,
do it.
I was on, and I'm gonna out myself here. I was so guilty of this when I was going through because I'm out myself because I made that mistake so often because had always felt like when I was going through this, I was somebody like I had done research, like I had done actual research. I had been the experimenter. I put the data together. I felt really comfortable looking at data. And so when I first started doing my kind of my MCAT passages, I did not have a structure. I would just like go and look at the trends. And then two major things would happen all the time. One, sometimes I was just super overwhelmed by what I'm looking at. I'm like, what am I even, there's multiple lines going on. Some are going up, some are going down. What am I even looking at? Where 90% of the time, if I just looked at the title, I'd know exactly what I'm looking at. Or it's the kind of second thing that happened, if I wasn't overwhelmed, it opened me up to such silly mistakes. And this is kind of, I know my blood curdles just even saying that, because all the time I hear people say, oh, I made a silly mistake by, oops, I just missed that in the title. But because they didn't have a structure, it wasn't part of your game plan to look at the title. So why do you think it's at all reasonable to think that it's a silly mistake because I didn't read it? No, it's not a silly mistake. It's a structural mistake, right? Let's change our structure. And I did that so often, and then I realized, okay, I actually need to do this. Again, it's not if you're bad at interpretation, you need taught. No, everybody should be going through taught, right? Because it just helps in so many ways. So title, absolutely critical. And I also feel really good. Like if I read the title and I'm like, oh, that's just my research question. That's just a reaffirmation. Like, okay, I understand what's going on. Like, okay, like a little pat on the back. Okay, like, okay, that's what I thought was going on. That's just a reaffirmation. Amazing, great. I feel really good going into this. Even if it's just that confidence boost when you're in an exam is huge. This brings us into like the next part. Like, so first we covered T, always read the title. Right? It could be at the top or at the bottom. Right? That just because it's at the bottom, by the way, doesn't mean it's not a title. It's a caption, it's still the title. Next is A and U, and I like to combine axes and units together, like because like your eyes are going to the same place, so they're normally the same thing to go. So I combine axes and units. So let's break them down one at a time. Axes are your X and Y axes on the graph. If it's a graph, if it's a table, it's going to usually be the top bar and maybe the leftmost bar, usually. Of course, there's always exceptions out there. And this is where, when I'm looking at my axes, I am paying attention to what are my independent and dependent variables. This is the time to be doing it because usually the axes are where they're going to be putting your independent and dependent variables, at least, right? And this is kind of one thing I like to add, where sometimes experiments will have multiple variables, multiple independent variables. So if it's because sometimes they might have one independent variable on the X, usually the dependent variables on the Y, but then there's maybe multiple lines. So there's sometimes a legend, right? Where it's like, oh yeah, these are like different concentrations we use. These are the different drugs we used. It's in the axes step that I also like saying, okay, what's my independent, what's my dependent? Because sometimes like maybe they said in the methodology, but maybe it wasn't clear. It's in the graph. This is where, okay, I just want to be very clear. What are my variables? Because all the time, they ask questions about these variables, but what was the relationship between them? Or when we change one and not the other. It's in the axes step, we look and we determine our variables. Some people ask, do I write these things down? Usually, I don't always recommend writing it down. As long as you like I think Molly put it well to like just clock it in, like pay attention. Like I like vocalize it in my mind. Like okay, time here is my independent, concentration's my dependent. Right? I have said that in my mind and I visualize that. Then I continue. If you find yourself like, Mike, that's not something that's reasonable for me, then I think it's okay for some people to do it when you begin, just to make sure that you are keeping yourself accountable, that you're tracking these things down. But as you progress, the goal is that you don't have to do that thing. So axes determine your variables. While you're looking at your variables, this is where the U comes in, which is your units. While you are looking at your independent, dependent variables, please, 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 for the love of everything, look at your units. This is, again, I'm going to just out myself all the time when it comes to data interpretation. I would not do this. I didn't have a structure. And so all the time when I would go to questions, I would make the silly, right, air quotations for those listening, mistakes. Because, I didn't see that it was micromolar instead of just molar, right? Oh, I thought it was just molar. I just missed that it was a nanomolar. Oh, it was actually in inverse molar and I thought it was molar, right? I didn't, because it wasn't part of my procedure to actually look at the units, I would just ignore them. I would just overlook them. So while you're looking at your axes, determining your variables, take a look. What are your units there? Usually when they're like standard units, I'm not like too concerned. Like if it's molar, if it's seconds, I'm not like, okay, cool. But if it starts being some non-standard unit, like it's like nanomolars, or if it's in minutes, I'm clocking that. They love turning minutes they love making it minutes, and then you have to convert to seconds, especially in Chem Phys. So I'm paying attention like, maybe even jotting it down, like just making like a little minutes thing just to remind myself like, if I have to do any math with this table here or this graph, I need to make sure I do that conversion.
Yeah. And also something else to note here is when you're looking at your axes and your units, especially if you have multiple graphs that are given that are like basically they look the same, right? Like, oh, you both of them are showing reaction coordinate diagrams. Okay, they have the reaction progress, right? Or like time of the reaction on the X, and then it's concentration of something or enzyme or sorry, free energy. Make sure you pay attention to not just what the variables are, not just what the units are, but also what the scale is of the X and Y axes. Because I've fallen for this multiple times where like on, let's say the graph to the left, again, same data, maybe they're showing, enzyme 1 kinetics and enzyme 2 kinetics in the second graph. They're right next to each other. They look the same. But on the one on the left, let's say to go from the bottom to the top of what's being shown is a factor of 10. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. On the one on the right, even though the graphs look the same, it goes from 0 to 100. Okay, so the graphs look the same. The shape of the graphs is the same height if you compare the y-axis, but on the graph on the left, that height on the y-axis corresponds to, let's say, 8, whereas the one on the right corresponds to 800. Okay, so especially when you have multiple graphs that are meant to be very similar to each other to show slightly different cell types, how does this proceed in a liver cell versus a muscle cell or something like that. Whenever you have similar diagrams, pay extra attention. They love to do this. Like, watch the scale of the axes, especially the Y, but it's good practice to just always look. What is like the lowest and the highest value for each that is represented in these diagrams? And if you see that they are different, that is warning lights flashing at you. They want to see how much attention you are paying this diagram. And that is something that had tripped me up many times. Okay. And this comes in with the trends. Okay. And I want to kind of just recap. We have TAUT, title, axes, units, trends. TAU so far, a lot of students are like, I don't need that. Most of the time they're going to ask me about the trends. And really, yes, most of the questions you see are going to come from the trends. You also, though, can get questions about variables. There might be new information in the title. Okay, you might need the units for calculations. That being said, not only are those first 3 steps helping you with those other types of questions, but again, to think of a puzzle, TAU lets you take a look at the puzzle box and see what I'm about to put together. Okay, it tells you what story could be told here. It gives you all the major players in the story that you are about to read or analyze from the trends. Okay, it's absolutely critical. Like, please, TAU, you need it. The questions are going to come from the last T that we're about to talk about. But if you don't have the background info and the like sort of mental organization of TAU before you try and find the trends, you probably won't find them. Okay, you probably won't because it's so critical to build that framework. Okay, when we talk about trends, we are basically just figuring out what is going on with this data. I understand the axes. I understand the variables that I was looking at. I understand the context given about the research question in the title. Now what? Okay, this is when you start to use what you've applied. Okay, so if there's a legend, if there's information on the axes, what is changing? Okay, and this is a place where a lot of students stare for a very long time. It will get much easier with the background information you've gathered earlier, which should be pretty fast, by the way, maybe 10 seconds, 15 seconds, nothing crazy. The trends, because you've already laid all the groundwork, typically this is much easier than it probably has been historically for you, right? When you're sitting down for the trends. If anything is immediately obvious of like, oh, this bar is way higher than the other one. Okay, what was going on with that bar compared to the other, right? Like, did we add a new enzyme? Was this in a different cell type? Why is this one high? Okay, you've now got all the context. You understand the key players in the story. Do you understand this? Right? You don't have to understand why it's taller, but can you recognize what is there? Okay, and if you do, this is actually a great time to make a quick note to yourself. Okay, if you look and you're saying, okay, here's my trend, and it becomes clear, right? Oh, this increases when I add this dependent or independent variable. This is a great time to pull out your pen and paper. Until this point, I don't really like jotting things down. Some students write out the research question and write out, this is my independent variable, this is my dependent variable, these are my controlled variables. You can do that, but what I recommend, and you'll see this in a lot of our video solutions, I know a lot of our instructors do this. If, let's say, you are looking at figure 1, you've done TAU, you're at the trend step, you look, and now it's becoming a little more clear. Oh, this bar, when I make this mutation, it has this effect on my dependent variable. You could write, for example, F1 for figure 1, colon, plus a mutation equals an increase in activity, right? Very short, sweet, lots of symbols, but like basically the framework is an F or a T, right, for a figure or a table, and the number, and then some change in your independent variable, right? So up or down, adding, removed, right? What did I do to my independent variable equals what change in my dependent variable? And that's it. So you get in that very quick note, which again, couple words, lots of abbreviations, lots of symbols, you get your independent variable, your dependent variable, and your trend, right? And of course, your research question is just your variables. So you've written down in one very compact little note everything that you truly need to understand. Okay, and if you've done TAU and you look at the trends and it's not clear, and you're not sure what's going on, that's okay. Okay? Don't force it. Don't punish yourself. Sometimes you have some complex figures. Okay? It's okay as long as you've done the background work and you've given yourself a solid shot. If you need to, right? Move on. Okay? If you want to jot down the independent and dependent variables and just leave like a question mark, I don't know how these things are related, that's fine. If you get a question about it, at least you know exactly what information is there. You will know where to look because you've already done TAU. That is the most critical thing. Questions come from trends, but TAU helps you find where in the passage you're looking when you get to the questions.
Absolutely. It's kind of like a North Star there. And you bring up a really, really great point about the trends, because sometimes the trends are very clear, right? Like in your graph, you see the lines going up, but then the lines are really separated, right? When you had this independent variable versus that one. Okay, trend is very clear. Adding this drug, increased rate, whatever. But a lot of times, especially this happens a lot with tables, right? When you have a table with like, okay, you have all these tables, but there's so many numbers everywhere. Right. When I see all these numbers everywhere, I see students get super overwhelmed. They're like, oh my goodness, like I can't see a clear trend here. Like it's not even like there's a trend, I just don't understand what the trend is. I just don't see one. In that case, totally okay. My kind of rule of thumb when it comes to trends should take 5 to 10 seconds to notice. Like if you don't see the trend within 5 to 10 seconds, move on, right? Write down like what are my variables here. At least you, again, actually took the effort to look. And so that if a question, a lot of times when it's like, especially a table, a lot of times questions are going to be very, very specific. A lot of times they'll tell you, oh, where specifically do they need to look? Maybe you don't need to know the trend of the entire thing, but maybe, oh, just one column. What was the trend in the one column? Okay, so now you knew where that question was because you did TAU, but now the question's kind of directed you, where do I need to look at the table? So that one, now I didn't need to waste quote unquote my time just trying to look for a trend, even though I didn't know what to look for. But now the question, I know what's there, I can do it efficiently, I can get what I need and answer this question effectively. So kind of my rule of thumb with students is like, try to get the trend 5 to 10 seconds. If you can't, move on. It's okay.
Yeah, absolutely. And there's one thing that we haven't actually hit on yet, and I just realized, and I'm like, oh wait, this is so critical. If you see statistical significance anywhere in your graph, and I'll tell you what that is and how to recognize it, but if you see it, that is your trend, okay? So typically you'll see a note in the title. Again, read your title, okay? And it'll say a note, typically it's an asterisk. An asterisk indicates that a p-value is less than 0.05, okay? A p-value is the probability from 0 to 1 that the results that you see, okay, so they're typically comparing differences between data points. It's the probability that that result is due to chance. Okay, so if you want to have a high confidence in your findings, if you want to say, oh yeah, there's something weird going on with this data point compared to a control, you want p-value to be low, because that's the probability that that's random. Okay, so if you have a p-value of less than 0.05, you're basically saying there's a less than 5% chance that whatever trend I see here is random. Okay, some graphs do not tell you anything about significance. If you don't see anything about a p-value, if you don't see any stars, then you just use your eyes. Okay, if it looks like it's going up, it's going up. Okay, if it looks like it's pretty much the same thing, it's pretty much the same thing. If one goes up way higher than another, which increases slightly, you just use your eyes, you use your best judgment. But if they have told you somewhere, either they've given you in a table what the p-value is, or if they've told you that they will put a star if it's significant, anything that does not have that star or that does not have a p-value of less than 0.05, it is not significant. And this is really, really weird because let's say in a table, okay, you had your independent variable and your dependent variable. They're represented in your table. You've got different values for your dependent variable given each trial, but they've also given you your p-value. Let's say your original value for your heart rate when given a drug was 80 beats per minute. Okay, they give you the drug and you are now at 90 beats per minute. My eyes, heart rate went up. Okay, if they tell you though, the p-value for that difference with the drug and without the drug was 0.1. And this is so confusing when you get to the questions. The drug did not have an effect on the heart rate.
Right.
If they tell you significance, you cannot trust your eyes. Okay. The number went up, but because it was not a significant difference, because there was a 10% chance that that was random, I can't trust it. I cannot conclude that there was any relationship between heart rate and the administration of that drug. So I'm so glad that we thought about this. Like, oh my gosh, wait, it's critical. Okay. If you have statistical significance somewhere and you are on your final T step, it's basically like a giant flag, like, hey, look at me, I'm your trend. Anything else that does not have an asterisk or a p-value less than 0.05 isn't important enough. It's not significant. Okay, so that I think is one of the weirdest things about navigating database questions. There are times with statistical significance there that you are not allowed to trust your eyes. That numbers are close enough and we just ignore it.
Right, which is sometimes tricky and like not intuitive. And I'm so glad that you brought this up because I've seen so often, right? I'm like a lot of times, so how a lot of like tutoring works is that, you do the exam, you review the exam, but then during tutoring sessions, you like go through the exam together. And I remember I see this all the time where a student goes through the exam, reviews it, and they're like, but Mike, look at that. Look, can't you see that there's like a few pixels of difference between the heights? And you're like, well, like, yes, I can see that, but was that significant? Right? You can see the bars there. Or like, was that a significant difference? Did they give you a p-value? Was there an asterisk there? No? Well, then you can trust it, right? You can't, even though it looks, right? Oh, especially there's even, I think, one of the exams, like a table where like one of them was like, one of the values was like 1.00 and one of the values was like 1.03. And then like, it was like, oh, but look, it increased. But it's like, okay, no, that wasn't significant. They didn't give a p-value, but like based on what the other numbers were, it was like there's close enough to say that there was no difference there. And so a big kind of key is recognizing significance. Just because there is a difference, we don't know that's significant. So I'm really, really happy that you kind of remind me because that is so, so critical when talking about data interpretation. I think, right, and like we kind of mentioned this before, like how important TAUT is, TAU, and if you can T, right? Because it avoids pitfalls. It avoids common mistakes we see. Like I was kind of mentioning before, I've made so many of these mistakes, right? Where, you like just completely misunderstand. Like if you don't do TAUT, right, you can completely misunderstand what you're trying to measure. Maybe you read the research question, but because now you just jumped into the graph, like maybe you just like to skip the trends. You're trying to get to the top of the stairway without doing the kind of taking the steps. You're trying to skip the trend, and now the y-axis says, skin conductance, and you're like, what am I even looking at here? Like, why is it saying this, right? Where maybe in the title they said, oh, sympathetic nervous system as measured by skin conductance versus time or something like that. Or maybe there was a critical note. Oh, they do this all the time. I don't think we mentioned it, where sometimes they put a really critical note in the title, or even sometimes where you look at the title, but then we just ignore the note because we're like, oh, it's not part of the title. No. The note is part of the title. please read the note. There's a reason it's there. There's a reason they're like, oh, wait, please read this right before you look at it. So a lot of times we can miss easy things, but then what kills me after is when we review, we're like, oh, that's a silly mistake because I didn't look at it. It's like, no, 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 it's not silly. There's no such thing as a silly mistake, and I will die on this hill, right? It's just a procedural issue. It's a structural issue.
Yeah. And taught really does help. Okay. Whether you tend to skip passages or skip, data altogether, it's obviously not helpful. If you tend to stare at it for way too long, because again, to think of the stairway, it's like you're expecting to just materialize at the top of the stairs. Like, no, walk yourself up. Okay. If anyone can jump an entire story, more power to you. But no, you need to walk up. That's the only way to get up. Okay. Do your TAU. If you don't have time for trends, do your best with it. But TAU is the minimum. Okay. Don't skip your title, right? Don't skip your axes. Don't ignore your legend, right? Make sure you look at units. Make sure you look at the scale of your graph. And then do your best with the actual trends that you see. Again, don't spend too long on it. This is like you are walking your way up the stairs and now you just have one extra step. Okay. You could move past it and come back to it later if you need it. You're so close to your full understanding of the figure that like you put enough groundwork in. You're okay to go to the questions if you can't figure out the trends. But I think having a set like procedure for this not only helps you increase your accuracy on practice, but it's giving you this layer of like almost foolproof strategy for when your brain is tired. I think a lot of students that are not doing full length practice currently kind of take this for granted, right? Like oftentimes we study when we're pretty awake and maybe not entirely exhausted. Some of us worked, or work while studying. So maybe you go to work, you come home, you're a little tired, but you study, you're okay. You maybe only do like an hour or two. Like you are going to be tired when you're on your test and you're going to be stressed. So even though you might not need a procedure like this right now, doing a handful of passages a day, trust me, to have this to fall back on when you're tired and you're stressed and, tensions are high, it changes the game for students. Okay. There's lots of places to get practice with this. Of course, it's going to require a lot of practice. Knowing TAU is not enough to be able to apply it, right? We have like 7,000 free questions on our website. I would definitely recommend checking out our AMC style material in our Q bank. There's lots of data to interpret in there, fundamental stuff as well, but AMC style is meant to mimic the way that AMC asks questions and the connections that they'll make. And I think our data is maybe a little bit harder in those passages. So
That's a good thing. That's a good thing.
Which is a good thing.
Practice for the hard stuff. You're right.
Yeah. Fundamental, just to clarify, our fundamental content is more topic specific. It's still very representative of how AMC asks questions, but they're not going to ask you as many interdisciplinary questions. So if you want to practice with the really hard stuff to make sure you solidify this taught strategy in your head, AMC style is a great place to go. Again, not going to see it in cars, but in every other section, yes. And make sure that you are going through this in that set procedure. Okay, if you struggle with the figure, ask yourself, did I look at the title? Did I look at the axes? Was that part of why I did not understand it? Okay, it's very important that you get practice with it. We also have so many videos of instructors breaking these down. We do them live in our science workshops every single week, as well as in science office hours, which we hold every week. We also have AMC video solutions. We have video solutions for our dailies. Okay, so many places. Many places. If you're like listening to this, and you're like, man, TAUT taught sounds really great, but like I want to see how it looks. Like we don't have data on a podcast format. Like we're kind of limited to go through it. But if you want to see it, there's so many places to go see it, which I think is really, really great. And all these places. And plus, you can also like come live to our session. We hold FTSs all the time, free trial sessions where sometimes, we talk about taught, especially when we talk about science passage. We'd have a session that I hold about reading MCAT passage, mastering MCAT passages, and we talk about taught there. And it's so, so critical. So if you're like, oh, I hear this, and I'm like, I want to see it broken down live, you're more than welcome to come to our free trial sessions. And a great place, now that we've talked about data interpretation and kind of like how to read, I think it's important that we know how to interpret data, but now I think it's important
to understand the bigger picture in research, because not all research is the same, Molly, right? Like we have all these different types of research, and understanding types of research, not only understanding, like interpreting the data, but understanding the bigger picture of research is a major skill to know for the MCAT, right? Because depending on the type of research, we can draw vastly different conclusions and say vastly different things. And that's going to be the topic of our next episode, where we're going to be breaking down types of research, but also really cool MCAT applications of these types of research. So we're going to be talking about, like, these are kind of the things like observational versus experimental research, the different methodologies that they can use for these studies and understanding these methodologies. And I think Psych Soc, probably of all the sections, really is what the section that tests on this was, but you will see this in all three science sections. I think it's going to be really, really important. So next episode, talking data interpretation, which I'm looking forward to.
Yeah, we know how to interpret data, but now what?
Now, right.
Yeah, and we get to talk about a couple cool, wacky studies that you are responsible for. So next episode should be
and
super
maybe
fun.
ethically ambiguous as well.
Ethically ambiguous for sure, mostly in Psych Soc. Human subject research, just, we don't have as much control over human subjects as we do a lab rat or a cell cultured, it gets a lot stickier. So we'll talk all about that next episode. We hope you guys enjoyed this one about data interpretation. Don't forget to practice. Happy studying, everyone. Have a wonderful rest of your day, and we hope to see you again soon.
Bye now, everyone.